another method, right? And again, this you can use. We have a lot of data, and so this may or may not be a useful method, but I think it's still something to consider. And it's called bootstrapping. And it's another way to evaluate. And this may be teaching a method in search of a question, but at least this is something that I think maybe more you could use more frequently. And what happens with Bootstrap? The procedures resamples the data to create many simulated samples. All right. So instead of just, here's my sample of data that I have, right? Well, let's go in and randomly assume that we're going to have all of those same transactions potentially happening many times. Sometimes they may be distributed one way versus another. Let's just randomly sample out of the population and pull another sample from the population. And we'll pull multiple representative samples from the population. And then from there, all these different populations, then let's calculate the means and standard deviations from all these populations. And then let's take a look at the mean of the means, right? If you weren't exposed to bootstrapping or samples of samples in your undergraduate statistics course, I recommend, if this seems interesting to you, to go and do a little bit of, you're going to have to do a little bit of research back to your statistics classes. The one thing that is great about Python and other programs, I mean, I can even do it in Excel, is that I can quickly create a set of bootstrapped samples and calculate the important estimates of mean and standard error across all the different samples, right? And we can use these more precise estimates to determine whether our inferences, our predictions are appropriate. All right? So there's a new package that I need you to install if it's not already installed, and it's called Scipy, right? Scientific Python. So go to Conda, install Scipy, okay, and install it. All right, I've already got it installed here, so I'm not going to rerun that script, but you'll want to use that to do the installation. All right, so let's get our basic stuff here. I'm going to create a new cell, so I'm going to import pandas as PD. I'm going to import Scipy as stats, and not stats, it's just stats, and I'm going to import numpy as np. So those are going to be the things that I'm going to use. All right. Also, from scipy.stats, import bootstrap. Okay, so I'm going to just, and let's read in our data. So df equals pd dot, right, read csv. All right, we're starting to get really familiar with this. Sales final 302021.csv and df sales date. So I got the wrong brackets on there. Come on. Sales date equals PD to date time. Oops. There we go. DF sales date. Beautiful. All right, so I'm going to run all this. Run that cell. Excellent. All right, so while that's running, let's put some more text under here. Okay, so when I'm trying to create okay, so I in a couple of rehearsals I tried doing this bootstrap, and I tried doing it. Remember, we had done a query for just all things store 76 and store 34. Well, when I tried to create a bootstrap sample, try to get more bootstrap samples. Remember, there was 800 and some odd thousand observations there. I ran out of RAM because it had to create 100 different new samples with 864,000 observations. It's a size problem, right? And it's a big problem. So if you think about the size of the problem, the store 34 data frame, like I said, had 400,000 records, and if I ran 10,000 resamples of data, that's 40 trillion. That's 40 billion pieces of data. 40 billion. Right? So be careful what you're resampling. All right? So if you think about the size of the problem, store 34 had over the store 34 data frame. If I ran that separately, had over 400,000 records. If I run 10,000 resamples, or even 1,000, but we'll say 10,000 resamples of the data, that is 40 billion pieces of data. That's too much data. It's way too much data, okay? The other issue I had was getting the data frame into a tuple, okay? So what, I mentioned tuple before. Okay? A tuple is immutable. It cannot be changed, right? You can't go in there and replace things. This is what it is, right? That means it cannot be changed. The values in the tuple cannot be altered like a list or a dictionary or a data frame or a series. So when the bootstrap command looks at the data, it wants immutable data that it can resample. All right, to convert any data into a tuple, place all the elements inside a parentheses, right? We've seen that when we've created some tuples before. I didn't tell you what it was, but that's what you do. And each item is separated by commas. If you have one item in this case, a series of data, then it is just the series with a comma after it. All right, so I'm just gonna put a little wording in here to describe what you're about to see. Get some space here, beautiful. Okay, so we're gonna put this in a new cell, df test. I just want to get the query, df query, and we're gonna bring in store equals 34, okay? That's what we're going to get. And you'll see that df test, I told you it has 400,000 records, 423,000 records. All right. So what I'm going to do is I'm going to group it by sales date. So grouped, we're going to say df test, group by, in this case, we're going to group it by, not sales date. Okay, and then I'm going to create a summary. Df summary is going to be equal to grouped, and I'm going to look at sales dollars, and I'm going to aggregate, and we're going to go np sum because I know that's in there. Okay, so let's run this whole thing here and see what we come up with. Right, so I got my df summary. I have a series of 361 days where I had sales in this particular store. Okay, even though it's 365, so a few days they weren't open. So let's take this summary and create a tuple. Df summary. I'm going to convert this to a tuple. And the way to do that is put it in parentheses, df summary, comma. Now it's going to turn from a series to a tuple, right? And I'm just going to put a little note next to this so you know what this is. This takes the column of data and creates All right, so I'm just going to run this one line. You're going to see this change from a series to a tuple. That's a tuple, and there's one thing in it, and what's in there is a series, right? So you can open this. If you want to see what's in that series, there's your series, all right? So now it's a tuple. There's one item, and the one item in here is a series. Okay, so I've done all that good stuff. Now let's start creating the random bunch of samples selection, right? We gotta, so first thing we do is we gotta create a random number generator, so an RNG, and we'll use numpy, so it's np random dot default RNG, and that will be the random number generator we're going to be using is the NumPy default random number generator. We're going to set up a new variable called res, and that's going to be equal to bootstrap. Remember, I brought in that function from scistats, right? Import bootstrap. And what we want to do is we want to take df summary, right? That's a tuple. We want to take the mean, right? So we want to use the NumPy mean. We want to get a confidence interval. Confidence level, and we want to have that equal to, say we want a 95% confidence level, so 95.95. And the number of resamples we want, the number of times we wanted to resample, let's have it resample 10,000 times. And the random state is going to equal my random number generator that I've already defined up here. Okay? All right, then I want it to print for res the confidence intervals. All right, so let's run this. I'm gonna put, we've already got our data all set up, so I'm gonna put another cell here. I'm gonna run this cell, and what we should print out is the confidence interval. So let's run that cell. Hopefully it works. Did not like that. In resamples. Small thing, forgot an S. There we go. So our confidence intervals run from 64982 to 71,519 for store 34. And if we think back to what the interval is, we got, it's not that much different when we did the other intervals, right? When we did the intervals just with the data itself, looking at the margin of error when we calculated that earlier. All right? So I can do the exact same thing, and now we'll do it for store 76. Right? We can do the exact same thing for store 76. So what I'm gonna do is I'm gonna copy all this. The only thing I'm gonna change is store 76. Right? So we're gonna do the exact same thing, but now we're gonna go out here and put in store 76, and I'm gonna run this for store 76, and I'm going to run this for store 76 because everything else stays the same. So now my confidence interval is a low end of 56,861 to a high of 62,972. So what it's done is it's gone through and taken 10,000 resamples of my series of data, and it's come up with the mean of all those resamples. I've done it 10,000 different times. It's come up with the mean, and it's come up with the mean of that, and it's given me what the confidence interval is. I don't know. I think that's pretty cool. And now I can compare looking at these two to see if there's any overlap, and there still isn't. Store 34 is still better than store 76.